Hello, welcome to this lesson of our study of vectors. So in this lesson we'll go through how to solve some vectors questions that do not involve numbers, probably showing some relations between two or more vectors. Okay, so let's start. Our first question here states that if ABCDE is a pentagon, then you're supposed to prove that the resultants or the resultant of forces AB, that is, these are given as vectors. Okay, so vectors AB given as this AE, BC, DC, and ED with AC added to them. The resultant of all these will give you 3AC. So you can solve this question or this particular question in so many ways. You can choose to use a diagram where you draw the pentagon, or you can choose to go by the resultant force or resultant of vectors method. Okay, so to go by the resultant of vectors, when you talk about the resultant of a particular vector or particular set of vectors, then we are talking about the summation, the vector sum of all the vectors. Okay, so if you call our vector or our resultant vector R, then the resultant will be equal to summing all the given vectors. Okay, plus AE, then plus BC, plus DC, plus ED, plus AC. Okay, so these are the vectors given. So you are supposed to sum all of these, and that will give us the resultant. Okay, so in most of my videos I made mention of what we call position vectors. So this one I would use a method called using the position vectors to solve this. Okay, so when I talk about position vectors, I mean when you have vector AB, then in terms of position vector is given as OB minus OA, right? So this is what AB means. Okay, so we write the position vectors of all the respective vectors given: AB, AE, BC, DC, ED, and then AC. Then we'll try to sum them again and see. Okay, so like I said, let's go to the next page and try to write the position vectors of all of these given vectors. Okay, all right, so when you have vector AB, in terms of position vector, AB is given as OB minus OA. So always the last one minus the first one. Okay, so if you have AB, then OB here minus OA. Then the position vector for the other one, AE, okay, is also given by OE minus OA. Okay, position vector for BC, okay, BC is also equal to OC minus OB. And then position vector for DC is also equal to OC minus OD. Then position vector for ED, okay, so these are the vectors given, is also equal to OD minus OE. Okay, just pardon me my handwriting. Position vector with for AC is also equal to OC minus OA. So these are the position vectors. And we said the resultant force is the sum of all the vectors given in the question. So it's the sum of AB plus AE plus BC plus DC plus ED plus AC. But then we've written AB and the rest in terms of their position vector. So let's write the sum in terms of that position vector. So the position vector or the resultant was actually AB plus AE, okay, plus BC plus DC plus ED, then plus AC, right? And then we've written all these in terms of their position vector. So the resultant will be equal to AB is in terms of OB minus OA, and then AE is in terms of OE minus OA, okay, plus BC is also in terms of OC minus OB, plus we have DC, which is in terms of OC minus OD. Then we have ED, which is OD minus OE. and we have the last one AC, which is giving us OC minus OA. So this is what you have as your resultant. So the whole resultant force can be written in terms of position vector as that. So now let's do some cancellations here. Okay, so realize that we have OB, which is positive here. Okay, and it can cancel this negative OB. So this OB will take that. Okay, we have minus of the OB here. This one was it's a vector. I didn't bring the arrows, so okay, just pardon me with that. Okay, so you can cancel OB and OB. Positive OB and minus OB will cancel themselves. Then you go to OE. Okay, this OE here can take care of this minus OE, so that one too will go. Then go to OD and see if there is some cancellation for that too. Okay, so OD minus OD here and positive OD here. So you realize we are left with how many of the A's? We have let me use a different color for you. We have one of the minus OE here, another minus OE here, and another minus OE. So we have minus 3 of the minus of OE. So we become minus 3 OA. Okay. Sorry, I was saying OE is supposed to be OA. Okay. Then we have for the C, we have one of the positive C here, or positive OC. We have another positive C, and we have another positive C. Okay. So realize that the whole of this resultant, some cancelled out, and then we'll be left with R being equal to, we have minus 3 OA. So the OA, they were minus 3 of them. Then we had 3 of the OC, which is positive, so plus 3 OC. So this can be written as OC, okay, 3 OC. In terms of algebra, you can rearrange them, okay. 3 OC OA again, okay. And this can be written as 3 into OC minus OA. And this, what is this? Okay, if you remember in our previous one, I said that AC is equal to OC minus OA. So let's come back here. OC minus OA will give us what? AC. So this will give you 3 into AC. And then this is our required proof. We are supposed to show that the resultant is equal to 3 AC, and that we've proven it. Okay, this is correct, right? So now let's go to the next question. We have our next question here, which is ABC is a triangle, and that P, any point on BC. So we have a triangle ABC, and then P is any point on BC. Then if PQ is a sum AP plus PB plus PC, show that ABQC is a parallelogram. Okay, so you saying that you want to show that something is a parallelogram, you have to first of all know some properties of this figure, this parallelogram here we are talking about. Okay, so first of all, let's try to draw this. Okay, let's try and draw something out. We said that let me use a different color for the triangle ABC. So let's say I have this, I have that. Let me draw it proper. Okay, and I also have something like let me draw this as this, that, and this one. Okay, so let's say I have A, B, C. So this will be the arrows. Okay, and this is a triangle we have. Now I want to show that we are saying that P is any point on BC. Okay, so if P is any point on BC, then we can name here, let's say any of the points here, or we can name it here. Let's put it with a red color. Let's say this is P. Okay, let's say this is our P at this point. Okay, then if PQ, so there's a point Q somewhere that we don't know, is a sum AP plus PB plus AP or PC, show that ABQC is a parallelogram. Now ABQC means that this is how the arrows go: AB, A to B, then B to Q. So Q should be at a point like this, okay, somewhere like this, then Q to C. That's how the parallelogram is being named, ABQC. Okay, so from the name we can know that the Q should be at that point I've actually marked. So this is how the line should extend to. You should have an arrow like this and this going here. Okay, with our Q being at this point. Let's say this is our Q, okay? So if this is supposed to be a parallelogram, then CQ should be the same as AB. Okay, so if it's supposed to be a parallelogram, then AB should be equal to CQ. Okay, also AC, this part, okay, is parallel to this for a parallelogram. That's how it works. Okay, so AC should also be equal to BQ. So these are what we are supposed to prove. If you're able to prove these two, then indeed ABQC is actually a parallelogram. Okay, so first of all, let's start with the information given. Now we're given in the question that PQ, okay, is actually the sum AP plus PB plus PC. Okay, so we can go back to the question and look at PQ. Now from here, this is how our PQ look like. From here to here, PQ is from here to here. I hope you've seen what I've done here with the move line. Let me use a straight line for you. This is PQ from P to Q. Okay, now let's go ahead and take that triangle out and try to draw something. Okay, so from the triangle section, this is how we have a BC going this way, or BC in this direction, and we have C to Q, and we have Q to B, like this. Okay, from the triangle. So this is the place I've taken out. Okay, let me go and name them so that you know what I'm talking about. Okay, so we have our P somewhere here. Okay, this is our B, this is our C, this is our Q, and we have BQ and QC. Okay, so this arrow is also going this way. And now we've said that P to Q, which looks like this, okay, has been given. So P to Q has been given using this equation from the question, that PQ is actually AP plus PB plus PC. So let's use position vector to expand that. Now PQ in terms of position vector will give us AP is actually OP minus OA and plus OB minus OP plus OC minus OP. Okay, now I realize that is how we can expand that. Okay, so OP, we have one of the positive OP here. Let me use a different color so you understand or you see it clearly. OP will cancel this negative, so positive OP minus negative OP, and it goes like that. Okay, so now let's see. This whole thing will be giving us, this is minus OA plus OB, and that I can write it as OB minus OA, right? I hope you can see what I'm writing here. OB minus OA. Then this is the same as plus OC minus OP. So this is how this thing PQ has been able to simplify to. Has been simplified to OB minus OA plus OC minus OP using position vectors. Okay, now OB minus OA is the same as minus OA is the same as AB, the same as AB, and then OC minus OP in terms of position vectors can be written as PC. I hope you understand this. So in a long run, now PQ can be then rewritten into, or PQ can be given by AB plus PC from the question. So after simplifying what was given in the question, we can write PQ as AB plus PC. Now let's go back and clean some part and try to find other relations as well. Okay, so this is what was given, and in the question we've been able to simplify PQ in terms of AB and then PC, right? I hope you understand what I'm doing here. Now we have said that PQ is now equal to AB plus PC. So we should keep this. Now let's see PQ, okay, in terms of other stuffs. Can we write PQ in terms of other stuffs? Okay, I mean in terms of other vectors other than the one that we've done here. But PQ is actually equal to PQ, okay, can be rewritten as, in terms of these, you realize that this is a triangle. Okay, let me take that triangle out. I like using diagrams so that you understand. Now this is our PQ and B in terms of B, or maybe using C. Let's use the C aspect. Okay, let's use this aspect, this and then this. I have that. Okay, so from this above triangle I can get this diagram where my P will be here, my Q will be here, and my C will be here. So this is how the diagram looks like, and then P is going to C, PC, like that. So I've taken this side of the triangle. Let me use a red pen to show you. I've taken this side of the triangle out. I hope you understand that. Okay, so that is it. Now let's look at this and write some relation. But then from this diagram to PQ is actually equal to, you have, this is what you do in triangular vector addition. You try to check the ones, the arrows, the ones that are going the same direction. You see that PC is going to this direction, and then it's in the same direction as the CQ. Okay, but then the PQ is also in opposite direction to it, right? So these ones are coming here, and then PQ is coming that. So you sum the ones that are going to the same directions and equate it to the one that is going to the opposite direction to them. Okay, so PQ will be equal to, PQ is in the opposite direction with PC and then CQ. Okay, now let's look at this. From this diagram, this is what we've been able to deduce, and we are saying that this is the same. If I erase, shuffle it, I'll have something like CQ plus PC. That's my PQ now. Now with this first equation here given, let me use a green one for you to see. With this first equation, you are saying that PQ is AB plus PC, and at the same time we've been able to write PQ in terms of CQ and PC. Then they are the same, right? So PQ is AB plus PC, then it means that PQ is also equal to CQ plus PC from this diagram we did. This should tell us that they should be equal. So if I call this, let's say, equation 1 and call this equation 2, they are both equations for PQ, so I can equate them, right? I hope you understand this. So this means that I have, this is what we have, and then the second one was PQ is now equal to CQ, or is it CQ? Yes, CQ plus PC, right? And it is one equation, this is another equation. They are both equations for PQ, meaning they are the same. So I can equate this equation. If, let's say, I say x is equal to 2 plus, let's say, y, and I tell you that x is equal to 5, and I ask you to find them, then this means that x is equal to 2 plus y, x is again equal to 5. I can equate this equation, since this and this are the same variables, I can equate these two sides. This is what I'm trying to say. In the first equation, or in this equation, x is equal to x for both ones. So it means I can equate these two. So I can say that then 2 plus y should be equal to 5, because they are both for x, right? They are both for x from this. So let's use the same or similar situation for our vectors question here. Okay, I hope you'll be able to understand, because you need to get these things right before you can try to come up with a solution. Okay, so AB plus PC, this side of the equation then should be also be equal to this side of that equation. It should be equal to CQ plus PC. This is what we have. Now PC is the same as PC. You let me pick PC, or maybe let me pick CQ, whatever. Let me pick this PC to this side of the equation. I'll have AB equals CQ plus PC, okay, minus another PC, because I took this PC to the other side of the equation, and that this will cancel this, and that I'll have the last one being equal to AB equals CQ. Now let's go and check, is this a relation wanted to show? Yes, we said if this is supposed to be ABQC is supposed to be a parallelogram, then that means AB should be equal to CQ. That's the first relation we wanted to show, and now we've been able to show that. I hope you understand what I'm trying to say. And now we've been able to show that. So our first relation has been shown, because for a parallelogram, the two parallels or the two opposite sides should be parallel, meaning they should be equal. Okay, so CQ should be equal to AB, and that we've been able to show that using what we're being given in the diagram, and also some relations we're able to pick up. Okay, now let's go and show AC is equal to BQ. To show that, we have to use this triangle, some triangle BQ. Let me show you that one. Okay, you have to use this triangle BQ. Okay, and BQ, BC, and then CQ. Okay, so CQ, BC. So you have to use this triangle, rather, this whole side of the triangle, meaning the top side of the parallelogram. Okay, we have to use this side. Which color should I use? Let me use the green one. We have to use this side of the triangle. Okay, that side as a triangle, and then we'll be able to show that. Okay, so let me just show it from here. Let's use this triangle. I said we'll use BC, BQ, and CQ. Okay, so BC, Q. Okay, so in this diagram, you can see that these arrows are going this way, and then only this is going that way, which is a counter to them. Okay, so that means our BQ here should be equal to BC plus CQ. Okay, and that with that particular one, you have to just put it as equation 1. Okay, let's call it equation 1. And also, if you come back to AC and then the rest, okay, let's use the down part of the triangle of the diagram. Okay, let's use this triangle as well and see this side of the triangle. Okay, so if you're supposed to use that, then this is how the triangle will look like. That down part of the diagram looks like this. Okay, it looks like that, and that we have a, I hope you can see what I'm doing. We have our A here, B here, and then C here. So it's like this, and then AC. Okay, so now with this particular one, we can say that AC is also equal to AB, okay, plus BC. Okay, now I hope you understand this. AB plus BC, that's AC for you. Okay, and this is the same as saying that you have BC plus AB, right? Now let's look at this. We have BC here, we have BC in this. Okay, now I want to show that something AC is equal to BQ. Remember, in our first relation that we did, in our first relation that we did in the first equation, we said we've been able to prove that, let me go and show you. We've been able to prove that AB is equal to CQ. Okay, so if you come back and look at what we are doing here, AB is supposed to be equal to a CQ. So this AC is the same as BC plus BQ, because AB is the same as BQ. I hope you, or is it AB is the same as BQ or CQ? Let me see what AB is equal to. It's actually CQ. Okay, sorry. So AB is equal to CQ, not BQ. It's supposed to be CQ. CQ, okay? So now with this particular one, this is my AC now, okay, from this diagram and from the relation we did first. Now, this BC plus BQ has already been said that it's equal to what? BQ, right? From the first equation, that here, BC plus CQ is equal to BQ. And then AC is also the same as BC plus CQ. Then it means that AC should actually be equal to BQ, because they have the same things at the right side. Okay, both of them have the same thing. and that this shows that indeed AC is equal to BQ, which also satisfies the next relation wanted to prove. So since we've been able to prove these two, then it means ABQC is actually a parallelogram. Okay, I hope you understood this. So let's look at our last question for the day, then we'll just stop and do other ones as well. Okay, so we have our last question saying that two forces AB, AD, and AD are acting at the vectors of A, okay, of a quadrilateral, and then which is the quadrilateral is being called ABCD, and two forces CB and CD also acting as C. Prove that their resultant is given by 4EF, where E and F are the midpoints of AC and BD respectively. Okay, so to actually solve this, we have to pictorial, like you have to know the pictorial view of our vector problem here. Okay, so we'll have let's say that our quadrilateral looks like this. Let me put it here, and this is that. It never said that it was a regular one, so it can be any four-sided figure. Sorry, can be any four-sided figure. Okay, now I just did this because I wanted to let you know that or have you see what it looks really like. Okay, so let's say this is our AC, and that on AC we have E, which is the midpoint. E is the midpoint of AC, so we have that, and then we have this as well. Okay, I hope you understand this. So now let's try to call some points out here. We have A, B, C, D. Okay, and then we are seeing that at the midpoint of AC we have E. Okay, and then at the midpoints of BD we have, so AC, there is the arrow. Okay, let me clean and show you the arrow. It goes this way, AC. So at the midpoint, let's call this part as the midpoint. We have E, and then BD also go this way, and let's say we call the midpoint to be this part, and that's what we call our F. Okay, now with regards to this, we are seeing that AB is a force that is acting on this one. Okay, so AB is actually a force that is being acting on A. So AB is going this way and AD is also going, so they are all acting at this point, so they are going out. Sorry, and we have CB also acting, CD acting on C as well. Okay, so this is what we have. So you are supposed to show that the resultant is actually given by 4EF. The resultant is just summing all the forces given in the question. Okay, so the resultant then should be equal to AB, that's the forces given, plus AD plus CB plus CD. Okay, so this is what we are supposed to do, and we'll sum these. Okay, now to write these in terms of BF and whatever EF, let's take some triangles out of this one after the other. Okay, so let's consider this part. If you consider A to F, which looks like this, let me use a straight line. A to F, there's my F. Okay, so let's say A to F, which looks like that. This is my F, this is the points. Okay, so let's say this is A to F. Oh, the line is not drawing proper. These are A to F. Okay, let's take that out and try doing something. So these are AF. So this is how the triangle looks like. What I've drawn with the A to F, this is how it looks like. I want to draw it big so that you get to know what I'm trying to do here. Okay, and this is my F, this is my A, this is my B, this is my D, So this AD, this is AB. So that's how the triangle looks like, or maybe the diagram looks like. I've just taken that one out, and these are F. Okay, so let me call that part, let's say F, and this AF. Okay, so now looking at this, this means I have this. Also, I have this going this way. Okay, so you can actually look at some diagrams here, and I'm begging you kindly pay attention to this particular one, because I'm going to use a lot of diagrams here, and I'm going to use a lot of scenarios here. So you can actually first of all look at this triangle that goes this way. This triangle that goes this way, you can look at it first, then later we come and look at the triangle that goes this way. Okay, then we'll have a relation. Okay, pardon me, because this question really is very, very long, and that I'm urging you to just pay attention to it. Okay, so first of all, let's look at the first side of the triangle, which looks like this. Okay, let's say this. It's so I've been taking them out like that, A to F and to D. Okay, so this is what we have here, and then from this triangle, very simple, we can see that AF plus FD, okay, is equal to AD. Okay, so we keep that. I hope you understand this. Now, let's look at the other triangle as well, which look like this, straight like that. Let me increase this small. Well, that's no, it's straight like this. Yes, and with that is the same A to F, or is it to F? No, to B, then to F. Now this, I'm going to show you what I did. Now you realize that this is what I did. This is a triangle, the big triangle. I divided it into two. I divided into the triangle AFD, and also divided it into ABF. Okay, so ABF is the new one we are working with, ABF. Okay, so with this particular one, you can say that AB plus BF should be equal to AF. Okay, I hope you understand this, and that with this AB here will be then given by AF minus BF. I hope you understand this. So this is what we have here. Now let's look at this. With the first scenario, we had this from it, AD being equal to AF plus FD. Okay, that's what we had. Now let's go back to our resultant. In our resultant, we have AB plus AD. And with this, we've gotten an equation for AD. Let me call that equation 1. An equation for AB, which is AF minus BF. Let me call that equation 2. So let's sum that. Okay, so this is what I'm trying to say. We've said that AD or AB, let me write AB first. AB is equal to AF from the triangle I just took out minus BF, and that AD is also equal to AD is given by AF plus FD. Okay, so now with this particular one, I can sum the two. Okay, equation 1 and equation 2. If I sum these two equations, I have to sum the left side of the equation. So I have to sum this and this, then come back and sum these and these. Okay, so first of all, AB plus AD then should be equal to the sum of this and these. Okay, so we have to add that aspect, AF minus BF. Okay, then plus AF plus FD, and this will be equal to 2AF minus BF plus FD. Now let's look at something here in the diagram. BF, realize that in the main question, the quadrilateral, this one, ABCD, F is actually the midpoint, or the middle of BD, meaning that F here, this is the middle, then from here to here, from B to F is the same as F to D. Okay, so B and BF is actually equal to FD. They are the same. Okay, so because this is the middle, I have just a line, and if I divide it into two, then from this point to this point is the same as from this point to this point. So the vectors are the same. You just look at the arrows. So you have BF being equal to FD. Okay, they are going in the same direction, they are the same. So if I have BF plus minus FD, then I have to get 0 because they are the same. Or you are saying that BF is equal to FD, then BF minus FD is equal to 0, or you can say FD minus BF is equal to 0. Okay, so let's go ahead and check something. So you're saying that FD minus BF should be 0 because BF is the same as FD. So this thing will give me 2AF then plus FD minus BF. You can do it this way, or you can choose to see it ahead. Okay, so this is actually equal to 0 because they are the same, and so if I subtract, I'll get 0. This implies that in our resultant formula, okay, AB plus AD is giving us 2AF, because this is what we have. AB plus AD is now simplifying to 2AF because this side will give me 0. So at the end, I have AB plus AD being equal to 2AF, because I said that this side will give me 0 because they are the same, and that if I subtract, I'll get 0. So now let's look at an additional diagram or something like that. Okay, so here in the first place we took A to F. Now let's look at from F to C and see what will happen here. Then later I'll come back and analyze E. So this is actually a difficult task, but then I'm urging you to just stay tuned. So this is how that side also look like, and we have F somewhere here because the middle of B to D. Okay, so I have my B here, my D here, and my C, and that I have CF. Okay, that means going to this way, CF, CB, CD, because I have in the resultant equation a CB. In the resultant equation, I have a CB plus a CD somewhere, and I want to get this in terms of something. Okay, so now this is my F. Let's look at this triangle CFB, meaning from, and this one is also going this way, this is also going this way, so you can call that triangle CBF. Okay, so you're looking at this triangle from here to here from this side. Okay, I hope you can see what I just did. We are coming to look at some triangles, okay, and that will help us to solve the question proper. Okay, so looking at this triangle here, okay, I hope you've seen that. Now, so let's go ahead and open another page and look at that. So we're looking at this triangle that looks like this. They are not drawn to scale, so this is my F, this is my B, this is my C, and CB, CF, okay, and this is my BF. So now you can see that CF is actually equal to CB, CB plus BF. Okay, now I use the direction, so these two are coming in the same direction, and this countering that, and that the sum of the vectors in the same direction should be equal to that of the opposite direction. I hope you understand now. So now this will imply that we'll have an equation for CB, because in the resultant equation we have a CB, and we want to have that in terms of something. So CB should be equal to CF minus BF. I hope you understand. Now let's look at the other side of the triangle, which looks like this. It looks like this, and that. Okay, That is F here. Sorry, let me use a different color. That's actually F here, D here, and my C is here. So I have CD, I have CF, and FD. Okay. Now, with regards to this, you realize that CF and FD, they are going the same direction. So their sum should give you CD. I hope you understand. So you have here CD being equal to CF plus FD. I hope you can see. So all these triangles are from this particular big triangle. And in this, you should also take notice that BF is actually equal to FD. And that BF minus FD should be equal to 0. Or you can say that FD minus BF. So anywhere you meet these two, you should get 0. Okay, they are the same because this is the middle of this line. The whole line like this, F is the middle. So either half should be the same. So from here to here should be the same as from here to here. They are moving the same direction. So BF should be equal to FD. I hope you understand that. Okay, so now let's move to the next one. So we've gotten an expression for CD, which is in the resultant formula in terms of CF and FD, and we've gotten an equation for CB, which is also in terms of CF and BF. Okay, so now let's go ahead and write something. That means that if I'm saying that CB, okay, is equal to CF will be done very soon. CF minus BF, okay, and that our CD is also equal to CF plus FD. Then it means if I add these two equations, equation 1 and 2 here, if I add these two, then CB plus CD should then be equal to adding these two, which is CF minus BF plus CF plus FD. Okay, and this will give me 2CF plus FD minus BF. But we've already gotten a relation for this, that FD minus BF should give you what? FD minus BF should give you 0. I hope you understood this. So it means that my CB plus CD, this shows that CB plus CD is now equal to 2CF. Okay. So now we've gotten that, and that we also said that AB plus AD. Now CB plus CD should be giving us 2CF. So now our resultant. Okay, we come back to our resultant, which looks like AB plus AD plus CB plus CD will now be equal to, here when you sum these two you get 2AF, and when you sum these two you get 2CF. Okay, this is what you have. So this is equal to 2 into AF plus CF. That's our first part of our assignment to do. Now let's look at writing AF and CF in terms of EF, so that we'll be able to get our final answer. Okay, so let's write this. Our resultant is equal to 2 into AF plus CF, that resultant. Okay, now let's look at something, another diagram. Okay, so that's the last diagram you're going to consider, and with that we'll be fine. Okay, sorry, let's go to our previous diagrams. That's the main diagram we had for the quadrilateral. Now let's look at this diagram. I'm coming to use let me use a move pen. You're coming to look at this here. Okay, and then this is what I'm coming to do. I really want you to pay attention here, because the diagram I'm coming to take out here, you may not necessarily see. Let me clean this part. Okay, and well, let me do it proper. Okay, so let me clean some parts. I want to clean some small parts. Okay, All right, so I'm coming to look at this. AF is here. Okay, this is my AF. Okay, because that's my F, so I have AF to be here, and then CF to also be here. Okay, I hope you've seen that. Let me use different colors so that you see what I'm talking about. So I have AF to be here. Sorry, AF. Whoa, the thing is not coming, so kindly bear with me. AF is here, and then CF is also here. So that's more that triangle here from AC, then from C to F, then from F to A. This is a triangle I'm coming to take out. And that on that AC we have an E. Okay, so we have that. So kindly bear with mind, or bear in mind that this is what we are coming to do. Okay, so in the triangle, this is how it looks like. You have AC, then we have well, let me draw it this way. You have AC like this, you have AF, then from F to C. Okay, so let me do it this way and this way. I hope you can understand what I'm trying to do here. Just take your time to go through, and that I hope you'll be able to solve everything. See, then there's an E here, which is the midpoint of AC, and that we have another stuff to work with. Okay, so this is how EFs look like. Let me use a different color. This is how EF looks like from E to F, like that, with a red color. So we have AF going this way, AF in this direction, CF in this direction, and EF in this direction. So apparently we'll have EC, and then we'll have EA. Now know this, that if we're supposed to look at it, E is the midpoint of AC. That means that from E to A, okay, should be equal to C to E. This also means that if I have this is equal to minus EC, because I said that if you have, or let me say this, let me say something. Okay, let me put it that way and still have it minus EC, because CE is the same as minus EC. Okay, I hope you remember this. C is the same as minus EC. So this will imply that EA plus EC should be equal to 0, because EA is the same as minus EC. So if I pick minus EC to the other side, it becomes EA plus, we said that EA is the same as E to A here, is the same as moving from C to E. So that makes sense. And then EA is equal to minus EC, because C to E is the same as minus EC. And that if EA is equal to CE, then EA will be equal to minus EC. Okay. And if I pick this minus EC to the other side, then it becomes EA plus EC, which is equal to 0. So the first relation I wanted us to deduce is this, that from this diagram, EA plus EC is equal to 0. So now let's look at some simple diagrams here, or simple triangles here. Let's consider the triangle EAF. Okay, EAF is this, from this triangle. Let's consider that. I bet you will be able to finish everything here very quickly. So this is what we have. This is how it looks like. Let me say it that way. And I have A, this is my E, this is my F. Okay, this goes here, this goes here, and this goes here. And from this diagram, you can realize that EF is actually equal to EA plus AF. As our first equation, you should keep. Okay, EA plus AF. Now let's consider the other diagram. Okay, let's consider this diagram. Sorry, let me use a different color. Let's consider this diagram, or this triangle. Okay, that one will be a triangle. What's ECF, right? So that will be it. Now let's consider triangle ECF. This is how it looks like. Let me just, this is my E. Let me use a different color. This is my E, this is my F, this is my C, right? So it looks like this and this. And then EF is still the same as this. EF is equal to EC plus CF, right? I hope you understand this. Now this is also another equation we should keep. Okay. Now from the first diagram we had EF being equal to EA plus AF. Okay. So EF is equal to EA plus AF. That's the first one. Let's say this is one equation. This is another equation. Okay. Now let's look at something here. Let's add these two equations and see. If I add these two equations, it means I'm adding this side of the every side of the equation. So the left side, I have EF plus another EF should be equal to summing the two side, this side as well. Okay. So I have EA plus AF, then plus EC plus CF. Now let's rearrange here. EF plus EF will give me 2EF. Okay. And this will be equal to AF plus CF. Okay. Plus EA plus EC. But what was our first relation we had with EA plus EC? Let's go ahead and check. Is that EA plus EC should give you what? 0. We deduce that first. Okay. So that means this part is actually equal to 0. So you have 2EF being equal to AF plus CF. Okay. This is 0, and so we have that. Pardon me with my arrows because sometimes writing has become something, but I know that they are vectors. Okay. And that we've already said something, that the resultant is actually given by 2 into AF plus CF. But then AF plus CF is also given as 2EF. Okay. So the resultant will be equal to 2 into 2EF. And this will be equal to 4EF, which is the required solution we wanted to show that the resultant of the forces acting at the corners or the vectors A and C of the quadrilateral ABCD is actually equal to 4EF, and this has really shown it. Okay, I hope you understood everything, and I hope you didn't get yourself confused. If you are confused, kindly come back, watch it over again, know the diagrams I was using, and then you'll be able to be fine. Okay, kindly subscribe to my channel if you have not subscribed, like my video, comment if it really helped you, and that if you want me to add anything to the video, you can also talk about it in the comment section. Okay, thank you, and don't forget to subscribe once again. See you next time.